Hey everybody, this is Mr. Trinity, and this is our quarter two final review. So we'll go ahead and start with number one here. Complete the statement: if parallel lines intersected by a transversal, then blank angles are supplementary. So one thing to remember is supplementary means adds to 180. Okay. This is the two parallel lines intersected by a transversal. That's referring to this picture in number 2 right here, where we have two parallel lines and a transversal. And in this case, the only two types of angles that are supplementary that we have a name for is same side interior. Okay, so that's supplementary. So that's our correct answer. The other ones, well, it can't be acute because two acute angles can't add up to be supplementary, and alternate interior angles are congruent and corresponding angles are congruent. So the correct answer is same side interior. For number 2, they give us, we're looking at angle 1 here, which is 5x plus 13, and angle 5, which they tell us is 3x plus 17. Well, these are corresponding angles, which means that they're congruent. So we're going to set them equal to each other. So 5x plus 13 equals 3x plus 17. Okay. Subtract 3x from both sides. 2x plus 13 equals 17. Go ahead and minus 13. We get 2x equals 4. Divide by 2. Then we get x equals 2. Or letter D. Okay. All right. Number 3, same thing here. We have this diagram where we have one of our angles is filled in as 150. And we know that if this is 150, then any corresponding angle or vertical angle or really any of the obtuse angles are also going to be 150. And the remaining angles, the acute angles, are going to add up to be 180, so that's going to be 30, 30, 30, and 30. And we were looking for a measure of angle 5, which was this one, I believe. Yeah, so that's our 150 there. So the correct answer is A. Number 4. Sides of an isosceles triangle have lengths 3x plus 1 and negative 2x plus 16. The base has a length of 2x minus 5. What's the length of the base? So if there's no picture, we're going to go ahead and draw an isosceles triangle. And we'll go ahead and label our sides. So this is 3x plus 1. This is negative 2x plus 16. And the base is 2x minus 5. Now we know that the two sides are equal to each other because it's isosceles. So I can actually set those two lengths equal to each other. So we'll go ahead and do that. So 3x plus 1 equals negative 2x plus 16. They don't equal the base, so we can't set that as part of our equation, but that's okay. We'll go ahead and solve here. Add 2x That's 5x plus 1 equals 16. Minus 1 minus 1. 5x equals 15. We can divide by 5. And we get x equals 3. And we gotta be very careful here because there is an answer of 3, so we might be tempted to circle that. But if we read the directions again, we're not asked what is x, we're asked what is the length of the base. So we need to take that x equals 3, plug it into that base equation, and so that'll be 2 times 3 minus 5, or 6 minus 5, which equals 1, and so A is actually the correct answer. Number 5. Complete the statement. If parallel lines are intersected by a transversal, then blank. Corresponding angles are supplementary. Nope. They are congruent. So it's not A. Same side interior angles are complementary. Complementary means adds up to 90. They are not adding up to 90. They're adding up to 180. That's supplementary. So same side interior angles is not correct. Alternate interior angles are complementary. Nope, they are congruent. So the correct answer is none of these. What is the measure of the vertex angle of an isosceles triangle if one of its base angles measures 38 degrees? Let's draw the picture. So we got isosceles triangle. One of its base angles is 38 degrees, which means the other base angle is also 38 degrees, and we're trying to find the vertex angle here at the top. So there's two ways we could do this. We could simply add these 38s together and subtract it from 180, because we know all three angles add up to 180. Or we could set up an equation, x plus 38 plus 38 equals 180. So then x plus 38 plus 38 equals 76. And subtract 76. And we get x equals 104. Okay. Number 7. Are the lines y equals negative x plus 9 and y equals x minus 3, are they perpendicular? Well, let's take a look at these. So for this first one, in red here, the slope of that line, remember there's a little 1 in front of that, x there is negative 1. I'm going to write it as negative 1 over 1. Okay. And over here, this other line has a slope of positive 1, or positive 1 over 1. So remember, perpendicular means opposite reciprocals. So are they opposite slopes? Yep. Got a negative here and then a positive slope, so it's opposite. Are they reciprocals? Meaning, if you flip the fraction upside down, do you get the other one? And 1 over 1 flipped upside down is still 1 over 1. So yes, they are perpendicular. They are opposite reciprocals. Number 8. Given the slope-intercept form of the equation of the line that's parallel to y equals negative 3x minus 7. Sorry, give the slope-intercept form of the equation of the line that is parallel to y equals negative 3x minus 7 and contains 0.5, negative 6. So, first thing we want to do is we want to find the slope of our original line, which is negative 3. So our new slope is going to be negative 3 as well. we have our x and y. There's our y1. There's our x1. We then use our equation, y minus y1 equals m parentheses x minus x1. We're going to put this in point slope form and then we'll convert it later. So, all right. Well, we know what y1, m, and x1 is, so we're just going to plug those in. So we get y minus -6 equals -3 parentheses x minus 5. All right. Do a little algebra here. Whenever we have minus minus, we're going to change that to a plus. We'll go ahead and distribute that -3, so we get -3x plus 15. And then we're going to go ahead and subtract that -6. So y equals -3x plus 9. Okay. Something to note here. Even if we couldn't get all the way through this part, just by noting what the slope is, we could eliminate both b and d. So that really we'd turn this into a 50-50 multiple choice question. Just by knowing the slope. So a little hint there. All right, number 9. Name the smallest angle of triangle ABC. So the smallest angle is going to be across from the smallest side. So the smallest side is 5, and that's going to be directly across from the smallest angle, which is B. The largest angle would be C, it's across from 7, and the medium one would be A. Number 10. Points B, D, and F are midpoints. They give us EC. So EC here is 30. And then they give us DF is 23. And they asked us to find AC. Well, if we remember what our midpoints are, our mid-segments, the mid-segment is half of the corresponding length here. So this is going to be 46, and that's our correct answer. Okay. Which 3 lengths could form a triangle? So remember, for this type of question, the 2 smaller sides added together has to be greater than the biggest side. Okay, so for A, 12 plus 5, well, that's 17. And 17 equals 17, so that can't work. 2 small sides, 10 and 15, so 10 plus 15 equals 25. And that is going to be greater than 24, so that one works out. 9 plus 11 is going to be 20, which is less than 22, so that one won't work. And 7 plus 6 gives us 13, which is less than 21, so that one doesn't work. So our correct answer is B. Number 12. What's the measure of the base angle of an isosceles triangle if the vertex angle measures 46 and the two congruent sides each measure 21? Well, the 21s don't help us out any. They just indicate that these are in fact isosceles. But we do know that the base angles are going to be the same in an isosceles triangle. So that allows us to possibly write an equation. I've got x plus another x plus 46, and then all three of those angles have to equal 180. So then I get 2x plus 46 equals 180. I'm going to go ahead and subtract 46, no, 146. There we go. So now I get 2x equals 134 divided by 2, and we get x equals 67. Okay. Number 13, classify the triangle by sides and angles. So by sides, we need to first find the lengths of all three sides. So we'll start with AC here. To do that, we'll use our Pythagorean trick here. So that's 4 by 2. So that's going to equal the square root of 4 squared plus 2 squared, which equals square root of 16 plus 4, or equals root 20. Down here for BC, this is a 4 by 3, so that's going to be equal to 4 squared plus 3 squared, which equals 16 plus 9, which equals the square root of 25, which if we're clever, we should recognize that is actually a whole number 5. Okay. And lastly, our third side here, we don't have to do any work, we just have to count the units, 1, 2, 3, 4, 5, so AB equals 5, and so we got two sides of the same. That means that this is an isosceles triangle. Okay. That's classification by sides. To classify by angles, remember it's c squared blank a squared plus b squared. And if it's a less than sign, it's acute. If it's a greater than sign, it's obtuse. And if you have an equal sign, it's right. Okay? So in our box here, we're going to put our length. So our longest side, well, 5 and 5 are both going to be equal, so it doesn't matter which one we make the longest. But I'm going to put the blue one there. So we'll put 5 squared box, our other 5 squared plus root 20 squared. Okay, well, 5 squared is just 25. Again here, 25. And then a square root and a square cancel out, so that's just left over with 20. And 25 plus 20 is definitely going to be greater than just 25. Or sorry, 25 is going to be less than 25 plus 20. So since it's less than, it is going to be an acute triangle. So this is an acute isosceles triangle. Okay. Okay, find the area. So the way we're going to find area is we first find the area of our entire rectangle here. So that rectangle is a 4 by 5. The area of my box equals 4 times 5, which equals 20. And then from that, I'm going to subtract out this red triangle, which is going to be 1/2 4 times 2. 4 times 2 is 8, divided by 2 is 4 again, so that's going to be an area of 4. And my green triangle be 1/2 4 times 3. 4 times 3 is 12. Divided by 2 is 6. So this is an area of 6. Well, 20 minus 4 minus 6 equals 10. So my correct answer is 10. Alright, perimeter. This one's not too bad either because we already have the lengths of our sides calculated in question 13. So perimeter, so that would be area. Perimeter is equal to the root 20. Actually, do this. We'll do 5 plus 5 plus root 20. So we just need to find an approximation for root 20, which is 4.47. So 5 plus 5 plus 4.47 is going to equal, that's 10, and then that's going to be approximately 14.47. Okay, last question. Match the correct methods of congruence to the following diagrams. So whenever we have a diagram, we want to look for two things. We want to look for vertical angles, or we want to look for a shared side. So first one here has vertical angles, and that's going to make it side angle side. So that's SAS. One below it is, we only have sides here, but they all match. So 7 matches with 7, 8 matches with 8, and 9 matches with 9. So that's SSS. We have a shared side there. And then looking at where our angles are, so we have angle, an angle, and then a side that's not in between. So this is going to be AAS. And bottom right, we have a shared side. And that side is in between the two angles that are given, so that's going to be angle side angle. Okay, which leaves our last one, which ordinarily wouldn't work because it would be angle side side, but because this is a right triangle, we have a special case for that one. If we have hypotenuse and hypotenuse and a leg, we can use HL. And that's it for this video.